let us discuss Hausdorff property. It's very interesting. This property says if you have two distinct real numbers p and q, then it is possible to find disjoint neighborhoods also. So I will draw the diagram here. So suppose p and q. See, these are two distinct real numbers. They have clearly mentioned p is not equal to q. Then it is possible to find neighborhoods of p and q which are disjoint. So this thing we have to prove. See, what will I do? P is not equal to q. So therefore mod p minus q is greater than 0. Obviously, if p is equal to q, then only it value will be 0. Otherwise, mod is there, cannot be negative. So obviously it is greater than 0. So what I am going to do, I am going to take r is equal to mod p minus q by 2, which is obviously greater than 0 since mod is there. What it says mod p minus q means distance between p and q. We are taking half of it. That means this distance r, okay? And we are taking neighborhood around p with this distance r and neighborhood of q with that same distance r. So now I will prove that. Now we will prove that neighborhood of p with radius r intersection neighborhood of q with radius r is equal to 5. We are going to prove that these neighborhoods are disjoint, nothing is common there. Getting intersection is 5. This thing we are going to prove. Obviously, if we have p and q, if you take half distance between p and q and if you draw neighborhoods of p and q, obviously those will be disjoint. But see, we have to prove it. See, normally in mathematics, when we wish to prove something, we assume contrary. And by solving, we get contradiction somewhere and then we declare our assumption is wrong, and that's why we can write the result. Getting? So here also I will do the same. So let if possible, see what I'm going to consider, neighborhood of p and neighborhood of q, okay, with radius r is not equal to 5. What I am assuming, I am assuming exactly opposite to the thing which we want. Getting? So it is not equal to 5. That means they intersect. So that means definitely we can find at least one point belong to that. So let x belongs to, that's why we can find x belongs to neighborhood of p intersection neighborhood of q. So that means this point lies in intersection. That means that point lies, it belongs to both sides. So therefore x belongs to neighborhood of pr, neighborhood of p comma r, and x belongs to neighborhood of q with radius r. Okay, so see, no more spaces there, make a screenshot of it, then we will go further. So let us continue. X belongs to NPR, that means x belongs to p minus r, p plus r. Okay, so this is neighborhood of p with radius r, and what we have, x belongs to q minus r, q plus r. This is neighborhood of q with radius r. Okay, so x lies in this interval. It means p minus r less than x less than p plus r. See, it lies in this interval. That means x between their end point. So here also I can write, tell me what can I write here, q minus r less than x less than q plus r. Let me remove this part, it is not required now. Okay, so let us continue. Implies, what can we write? See, one thing we have, p minus r, okay, less than x, and x less than q plus r. So that's why we got this one. And getting q minus r less than x, but x less than p plus r. So we combine those inequalities in this way, a less than b, and but b less than c, so a less than c, and then a less than b and b less than c, that's why a less than c. So such type of thing we have done there. See, what will I do? I will take q on this side, I will shift minus r on that side. So p minus q, if you shift r on that side, it will have plus sign, so r plus r 2r. And what will happen here, I am shifting q on that side, I am taking r on this side. So minus r and minus r, that means minus 2r less than p minus q. Getting what I have done, I shifted q on that side, I shifted r on this side. So let us combine this thing. So yeah, what we have, minus 2r less than p minus q less than 2r, getting less than 2r. See, there is one result. So I'm going to use that result. That result is mod a less than b if and only if minus b less than a less than b. See, this result already we have seen, and we are getting inequality of this type, getting minus b, b. So here also 2r and minus 2r. So same kind of thing we have. Our value of b is 2r and value of a is p minus q. So if I use in this way, so what will I have, more p minus q less than 2r. Okay, but you remember, okay, I will write here, you remember the value of r is p minus q mod p minus q by 2. Right, mod p minus q by 2, that was our choice of r, and here mod p minus q we have. So mod p minus q is equal to what, 2r. So therefore we get this is 2r less than 2r. Is it possible any number is less than it itself? It's not possible. We get a contradiction. We get contradiction. So therefore our assumption is wrong. I will mention therefore our assumption is wrong. So what was our assumption? Assumption is wrong. So our assumption was intersection is not equal to phi. That is wrong. That's why intersection is phi. Therefore, neighborhood of P with radius R intersection neighborhood of Q with radius R is equal to phi. Yes, in this way we proved. Okay. So yeah, proof is over. Make a screenshot of it. Then we'll stop. Thank you. Bye bye.